Okay, we're going to look at numbers 3 and 4 in section 5.5. Very similar to numbers 1 and 2. We're going to find a formula for the function represented by the given integral. For number 3, this is the integral that's given. And so remember, we're going to use the fundamental theorem of calculus part 1. We need to find the antiderivative of e to the 3u, and then we'll evaluate it at x and at 4 and subtract. So be careful. The antiderivative of e to the u would just be e to the u, but this is e to the 3u. So notice I need the antiderivative to be 1/3 e to the 3u, because when I take the derivative of e to the 3u by the chain rule, I'll have e to the 3u times 3. And so to get the coefficient here to be 1, I need this 1/3 out in front for that to work. So this is the antiderivative of e to the 3u. I'm going to evaluate it at x, replacing u with x, and at 4, 3 times 4 is 12, and I'm done. There it is. I mean, if you wanted to factor out the 1/3, you could write it that way, I guess. This is what they have in Achieve. A piece of cake on that one. Number 4, also pretty easy, a little more work to do maybe. Here we're going to find the function, formula for the function represented by this integral. So I'm going to find the antiderivative of t plus 8. Well, that's 1/2 t squared for t, and then the antiderivative of 8 is 8t. We're going to evaluate it right at the upper limit. This time the upper limit is x squared, and the lower limit is 6. So be careful when I replace t with x squared, I get x squared squared, which will be x to the 4th, times 1/2, and then plugging it in plus 8t is x squared. So there's the evaluation at x squared, and then plugging in 6, I get 1/2 6 squared plus 8 times 6. 6 squared is 36, and half of that is 18. 8 times 6 is 48. So 18 and 48 give me 66. And so I'm going to have 1/2. This will be, remember, x to the 4th, multiplying those exponents, plus 8x squared, and then minus this 66. So there is the result. I think I looked in Achieve and they wrote 1/2 x to the 4th as x to the 4th divided by 2. Either one is fine. There is the function, the formula rather, for the function that is represented by this integral here in this one. So numbers 3 and 4, hope this is helpful.